Hello and welcome to Math 252, Calculus 2 here at Cañada College. My name is Lapuz, and in this video we will be doing checkpoint 3.14. This is from section 3.3, Trigonometric Substitution. So they want us to rewrite the integral using an appropriate trigonometric substitution. It says do not evaluate the integral, but I think it'll be fun and good practice to evaluate the integral, so that's what we'll do. Now we have a square root of something squared, or just an a constant value, minus x squared, and whenever we have something like that, we tend to gravitate towards trigonometric substitution so that we can write it as a trig function and use some trig properties to get rid of the square root. So that's what we'll do. The particular substitution in this scenario is to let x equal to, now there's 5 squared here, so we'll take the constant 5, and then this is going to be a something minus x squared, which will be a sine substitution. So we're going to let x equal to 5 sine theta. And then the dx, because we need to take care of the dx, will be the derivative of this. It'll be 5 cosine theta d theta. And so our plan is to change everything into a function of theta. Now the whole point in doing this is that this square root term or factor will become 25 minus parentheses 5 sine theta. That's the x value that we're putting in, and we're going to square it. And this will have a factor of 25 in there. And we have 25 minus 25 sine squared theta. And this will equal to 25. Let's do it like this. 25 times 1 minus sine squared theta, which will be a trig identity that we can write into cosine squared. That's 25 cosine squared theta, and that would just be taking the square root of that and give you a constant 5 and a cosine theta without the square root. So again, the purpose of doing this particular substitution is to be able to take advantage of a trigonometric function that's going to be squared, so that the square root can undo that. Okay, what do we have now? So our integral will then become, we have a 5 sine theta quantity to the third power divided by, we just found out that this denominator is going to be 5 cosine theta, and then we also have our dx, and that is going to be another 5 cosine theta d theta. All right, let's collect the 5s. There's a 5 here and a 5 here that would go away, so we have 5 times 5 times 5. That's 5 to the third power. 5 to the third power is 125 that we can take out of the integral. The cosines would also cancel, and all we're left with is the sine cubed theta d theta. All right, now we think back to the last section where we talked about trigonometric integrals, and we have a sine. If you have a sine, cosine, or a combination of sines and cosines raised to powers with the same angles, then we can try to use one of those algorithms. Here we have a sine to the third power. It's raised to an odd power. So I think the way we're going to want to do this is we'll keep the 125 out here, and we'll integrate this. We'll take one of the sines out, and then we will change the sine squared into something with a cosine. So we have 125 times the integral of sine squared theta times sine theta d theta. And then we will rewrite the sine squared theta as 1 minus cosine squared theta. And then we have a sine theta d theta. All right, from here we will do a u substitution. We will let u equal to cosine theta, and then du will be equal to negative sine theta d theta. So a sine theta d theta will just become a du, and then we do have that negative sign out there, so let's put a negative 125 and then the integral of 1 minus u squared, and then this whole thing just became du. Negative's already out there. We integrate this. This is going to be negative 125, and then the antiderivative of 1 is just going to be u, and then we have a 1/3 u cubed plus c. And we need to change everything back into the sine and cosine. So we have a negative 125. I'm going to go ahead and distribute this as well. And u was equal to cosine theta. And then this negative and a negative will become positive. And 125 does not go into 3, so we'll have to keep it as 125 divided by 3, and then cosine cubed theta. All right, we'll put the plus c here, but we're not quite done yet because our original integral was in terms of x, so we're going to need to change this back in terms of x. Now, we will use this original trig substitution that we had as a reference. So on the side here, say x is equal to 5 sine theta. And what we'll do is to figure out what cosine theta is with respect to this equation is to construct a right triangle, and then maybe rewrite this as sine theta is equal to x over 5. So what that tells us is that if we define an angle theta, the x is going to be the opposite, and then the 5 is going to be the hypotenuse. So we got an opposite over hypotenuse business happening. And from there we can figure out what the cosine of theta is by figuring out what the adjacent side over the hypotenuse is going to be. And we know the hypotenuse is 5, we just need to figure out what this adjacent side is. So this adjacent side will be, using the Pythagorean theorem, would be this squared plus this squared is equal to 5, so that's going to be 5 minus x squared. And it is not an accident that this looks like the integrand, the radical and the integrand that we had, because it's how we defined the trig substitution. So that would be our numerator. That's I'm sorry, this is 5 squared, so that's 25 minus x squared. And then that's your cosine. So wherever we see a cosine here, we will use this expression, and then everything will be back in terms of the x. So our final answer should be negative 125, and then here we have square root of 25 minus x squared divided by 5. And then we have a 125 over 3, and then we will have a square root of 25 minus x squared over 5 to the 3rd power plus c. So we can do various simplification processes here and then get the result that we are looking for. So I think that's it. All right, I hope that helps. Good luck.